Hey there, grade 6. New video for you guys today focusing on divisibility by 2, 3, 5, and 9. And so you're going to be in the workbook using different structures like number lines or base 10 blocks or hundreds charts to do what's called verified divisibility, which means will something be divisible by a specific number. The next one is kind of an interesting learning target to be able to see that the sum of two multiples of a number is also a multiple of that number. And then lastly, to discover and understand through pictures the divisibility test for 9, which is kind of a neat one actually. So here's where we're going to start. We're going to start with just a review of divisibility in multiples. We see this question here that says 15 divided by 3, which is 5. And the question is, what's the remainder? Well, the remainder is 0. And so since the remainder is 0, we can say these three things: that 15 is divisible by 3, that 15 is a multiple of 3, and that 3 is a factor of 15. So is 5 actually. Now, if we jump ahead one number from 15 up to 16, and we say 16 divided by 3, that's now 5, and then the remainder is 1. So because there is a remainder, because the remainder is not 0, we know that 16 is not divisible by 3, that 16 is not a multiple of 3, and that 3 is not a factor of 16. Very handy dandy. Now we can see this on a number line, right? So if we start at 15, which we know is a multiple of 3, then we move ahead 3. In other words, we add a multiple of 3 to that number, and we get up to 18. We know then that 18 is also going to be a multiple of 3 because we've just added one more 3. Also, we know then that 3 is going to be a factor of 18, which is very handy. The same works if you do subtraction. If you subtract 3 from 15, if you subtract 3 from 18, if you subtract 3 from 6, the question is, do you get a multiple of 3? The answer is yes, right? So then there's this rule here that by adding or subtracting 3 from a multiple of 3, you get another multiple of 3. And so when we do that repeated subtraction, we get this pattern: 15, 12, 9, 6, 3, and 0. These numbers here are all multiples of 3. We can also start at 15 and add 3 each time to write the 5 new terms in the sequence. And so if we are, jumping ahead each time, we have like 15 plus 3, plus 3, plus 3, plus 3, and then it goes behind my face, but plus 3 here as well. We end up with the 5 next multiples, right? 18, 21, 24, 27, and 30. Now, here's the interesting thing. If I do this repeated addition and I generate multiples of 3, I can sort of skip that and say, like, well, I know that 3 fours are 12, so I wonder if I just add 12 to 15, am I going to end up with another multiple of 3? And the answer is yes. If I start with a multiple of 3 and I add another multiple of 3, I'm going to finish off at a third multiple of 3, which is kind of a neat thing. That also works for subtraction. Okay, so here's the rule. I'll just move my face over for a little bit. It's kind of hidden behind the watermark, but the sum or difference of two multiples of a number is also going to be a multiple of that number. So we can use that concept to quickly figure out if a sum or difference is going to be a multiple of a number. And so here we're trying to figure out multiples of 7. I know that 21 is a multiple of 7, and I know that 14 is a multiple of 7. So because those two are multiples of 7, then I know that whatever number this equals, and it happens to be 35, that yes, that's going to be a multiple of 7. If I move on to 30 minus 12, I'm trying to find multiples of 6. I know that 30 is a multiple of 6. I know that 12 is a multiple of 6. So then I can say that, yes, that's going to give me another multiple of 6. Now, trying to find multiples of 8. I know that 32 is a multiple of 8, but 15 is actually not a multiple of 8. So that addition is not going to give me a multiple of 8. And then a couple more. Here's a subtraction question. We're trying to find multiples of 4. Again, I know that 80 is a multiple of 4, and I know that 16 is a multiple of 4. And so when I do the subtraction, I'm going to get a third multiple of 4. And then lastly, 81 and 24. uh, thinking about multiples of 9. 81 is a multiple of 9, but 24 is not. And so that will not give me a multiple of 9. And then lastly, 60 and 15, those are both multiples of 5. And so yes, that's going to give me another multiple of 5. Now, just real quick, multiples of 2. If the ones digit ends in a 2, 4, 6, 8, or 0, in other words, if it's an even number, those are all, like without fail, all going to be multiples of 2. Okay, so a number is a multiple of 2, even number, etc. Now, let's figure out all the multiples of 5. This one's also kind of a neat thing. I can just basically go shoom, down the one column and then shoom, down the next column. So all of these, if the number ends in a 5 or a 0, that is a multiple of 5, and 5 will divide evenly into it. This one's kind of a neat pattern. Here we're supposed to find and shade the numbers with digits that add to 9. And so, let's see. Actually, at this point, if you would like to pause it, sorry for the interruption, but you can pause the video here before we kind of carry on with 9. And you can do some practice in the workbook, page 127, I think it is. You can do about numbers 1 to 5, and then we'll pick up with the 9 stuff. So here's all of the digits that add to 9, right? So I have 9 plus nothing, 1 plus 8, 2 plus 7, 3 plus 6, 4 plus 5, 5 plus 4, 6 plus 3, 7 plus 2, 8 plus 1, and then all the way over here, 9 plus 0. All of those numbers add up, right? They all add up to 9, right? That goes down in a diagonal line, and start a new one over here. Where would you find these numbers on a times table chart? Well, hopefully you can figure out that they're on the 9 times table chart. 9 times 1, 9 times 2, times 3, times 4, etc. So here we have the next 3 multiples of 9. Then the question is, what do each of the digits of each number add up to? And so what we see then is we have 9 plus 0 is 9. 9 plus 9 is 18. 1 plus 0 plus 8 is 9. And then 1 plus 1 plus 7 is also 9. Okay, so when a number is a multiple of 9, the sum of its digits is also a multiple of 9. So the numbers together will add to 9, or it'll add to 27 or whatever else. Even a number here, like 18 is a multiple of 9, but if you add these digits, you will still be able to simplify it down, and the one digit number that it adds to will always be 9. So then we can use that idea about adding digits to predict whether a number is a multiple of 9. So you have 3 plus 7 plus 8, that's 18, and 18 is a multiple of 9, so yes, that one is going to be a multiple of 9. 4 plus 5 is 9, and 3 plus 6 is 9, and then 9 and 9 is 18. So yes, that's also going to be a multiple of 9. 1 plus 3 is 4, plus 4 is 8, plus 7 is 15, which is not a multiple of 9. And then 5 plus 1 is 6, plus 3 is 9. So yes, that number, 5,130, will also be a multiple of 9. So then is 54 a multiple of 9? Yes, the 2 digits add up to 9, but you can also test it out by finding factor pairs, right? Remember factor pairs, 2 numbers that multiply together, right? So if we're doing, actually I'm going to move this over here a little bit, I almost ran out of room. So I have 1 times 54, I have 2 times 27, I had 3 times, I can't remember, 3 times 18 I think. 4 no, 5 no, and then 6 and 9. And those are all the factor pairs of 54, right? So 1 times 54, 2 times 12, or sorry, 3 times 27, 3 times 18, and 6 times 9, right? So those are all, hooray, yes, factor pairs. Okay. And really, that's about it. The last thing I want to say is, remember with multiples of 2, they have to be even numbers for 2 to be a factor. For 5 to be a factor of a number, they have to end in 5 or 0. For it to be a multiple of 9, or for 9 to be a factor, the digits have to add up to a multiple of 9. And actually, the same rule goes for 3. If you add the digits and it's a multiple of 3, so it's 3, 6, 9, 12, etc., it will also be a multiple of 3. And there's a question in the workbook that sort of looks at the relationship between multiples of 9 and multiples of 3. It's actually kind of a neat question with some Venn diagram stuff. So anyway, that's it. That's divisibility. I'll spend a bit more time on some of the other numbers, like 6 maybe, and 4 to figure out if in subsequent lessons. So anyway, that's all for today. You guys have a great day, and talk to you soon.